Hi everyone, I'm recording a new video to go over the latest features that I've added to my Squire project. It has just hit version 0.1.0 and I wanted to demonstrate the latest things I've added to it. So let's go ahead and get started. First thing I want to do is I just want to show the cluster so that we have a little baseline of what we have to work with. And as you can see here, we currently have a 4 GPU machine and then 2 compute nodes. Do note that I do have another 2 single GPU machines, but they're currently drained, so ignore those. But the main set of resources that I have is a 4 GPU node and 2 compute nodes. Okay, if we look at the queue, we're going to see that it's currently empty, right? And what we're going to do is we're going to submit a set of jobs. Some are legit jobs, others have issues, exactly so that we can demonstrate the types of things that Squire can help admins and users with. So first job that we're going to submit is a job that basically has no wall time and it's just a sleep job, okay? So it's just asking for 1 CPU and 1 gigabyte of RAM, and it got job ID 272. Next job that we're going to submit is a dependency trap job. So we're basically going to submit a basic job that exits immediately, and then have one that depends on that job. And that got job ID 274. Next, we're going to submit a real healthy job. And this is just a training job that requires 1 GPU, 16 gigs of RAM, and 4 CPUs. And this is a legit one. So we want to submit it so that we can demonstrate how a healthy job looks like to Squire versus a zombie job. Next, apologize. Next, we're going to submit an idle job. Basically, we'll hold a card and does nothing. So this is basically that zombie job that I was talking about earlier. So this is we're calling it hold 1 GPU. As you can see, it asks for a GPU, 16 gigs of RAM, and it just sleeps around, doesn't do anything. Got job ID 276. And then next, we're going to do a partially used job. So what this is we're going to call it train 2 GPU. It asks for 2 GPUs, 16 gigs of RAM, but it's basically the same training job as before. And this job, as I actually coded it, it will only use 1 GPU. So it's good because we can actually use Squire to look at the actual GPU utilization and detect that we're wasting resources. That's why I'm submitting this one. And then lastly, we're going to submit a victim job. So this is a real training job, right? That is basically suffering from the fact that it needs 1 GPU and 16 gigs of RAM, but there's no resources available right now. So to demonstrate that, now that we submitted all these jobs, we're going to just run SQ. And what you can see here is that the train 2 GPU is running, the hold 1 GPU is running, the train 1 GPU is running, and the CPU no time is also running. Now, the issue though is that we have 2 pending jobs here. One is the wait 1 GPU and the other one is the dependency doomed one. And for the dependency doomed one, Slurm actually does a pretty good job saying that dependency never satisfied, but Squire actually has some mechanisms to actually give you a little bit more details and instruct admins and users on how to deal with these, because Slurm can actually be configured to get rid of these automatically, and a lot of admins might not know that. So, all right. Next thing we're going to do is we're going to actually deploy the 2 of the new tools that ship with Squire, and we basically have this squire-lint and squire-me. Okay, so all we're doing here is we're going to go to the GitHub repository and download those 2 binaries, and we're just checking their checksums to make sure that they are legit ones. Now, if I go here to the project, you'll see that these are available under releases. So if you go here, you can see the change log of all that I added, and in here these are the binaries. These are all included in the Squire Go project. So you can get the entire GitHub repository and clone it and compile it yourselves. It's just that we're basically like pushing this through a release so that users can just grab the binaries directly from GitHub. All right. So continuing on, next thing we're going to do is now that we have the binaries, I'm basically going to copy them into my my login node. Okay, so what we're doing here is we're deploying those binaries, the squire-lint and squire-me, into the temp folder of that login node. Now we can actually run them. So we're going to start with generating a token. Okay, so what we're going to be doing is we're logging into the login node, and we're basically running scontrol to generate a token for us. And the next thing we're going to do is we're going to run squire-lint. Now, what is squire-lint? Squire-lint is a standalone tool. It does not require any of the other Squire components. And as long as it can reach slurmrest API, which ships with Slinky project. So if you have Slinky project system, you can basically use this because you'll have the REST API up and running. But even if you don't, and you just have a Slurm cluster, a standalone HPC cluster on your infrastructure, your own fleet, you run, you just want to get insights into how your cluster is doing, you can basically just get the squire-lint, point at the Slurm REST API, and get information that way. So all we're doing here is we generated the token here, right? And then in the next step, we're basically logging into the login node, and we're running as Luis. And all we're doing is we're passing an environment variable that points to the Slurm REST API machine on port 6820, the REST API service. We pass it the token, and then we just run squire-lint. Now, this is a tool that users can run to basically get some more information on their own jobs, or admins can also run this to get information on everything that's going on with the cluster. And here you can see that we have two findings across all the jobs that we can detect. One of them is this one, CPU no time, and it basically says there's no time limit set. So it's just warning the user, look, the scheduler cannot backfill around a job with no end, so you're kind of wasting resources. You're not being very efficient by just leaving it open-ended, right? So this is something that you should look into and address. Then for the next one, it's the dependency doomed one, and it basically says that it's pending on the dependency. Slurm says it can never be satisfied, so it will queue forever. But if you're the admin, you can actually set kill invalid depend in slurm.conf, and this will remove these automatically. I did want to include these here because a lot of admins might not know about this. So I think it's, as I did some research, it seems to be a thing that comes up a bit. So it seems like a good test to include in the squire-lint application. So again, squire-lint is just something that ships with Squire. It does not require Prometheus or the DCGM telemetry on a Kubernetes cluster. This can be ran, you can run this standalone against your Slurm cluster as long as you have access to the Slurm REST API. So what we're showing here is that you can actually get that binary and just deploy it very, very easily. All right, next thing, we're going to actually deploy Squire. In order to do that, what we're going to do is we're going to clone the GitHub project, the Squire project, into temp squire v0.1.0. And what you're going to see here is that if we go to that folder, you're going to see that there's a deploy folder in here. And the deploy folder has two YAML files. One is the YAML that describes the Squire so that you can deploy it as a pod. And then, and before I move away from it, you can see here that it targets a specific image, right? So ghcr.io/lmsilva/squire, and this is the version that we're tagging to deploy. You can also see the arguments that we pass to it by default. This is so that we can serve on port 9101. In previous versions, this port was just used for metrics to serve a metrics endpoint to Prometheus. We're now actually using this to serve other web content, and I'm going to cover that in just a second. But just wanted to make that clarification or give that context for how things used to work versus how they're working right now. And then other things are like the Slurm URL. This is the REST API, the URL to the REST API. The Prometheus URL, so that we can get telemetry from the DCGM. And then the Slurm token. This is basically the file that contains the token for the service. And the reason why we did this is that we currently don't have an elegant way to just have the token automatically refresh. And because of that, I made it so that we read the token from a file, and the idea is that we can basically push a token externally into the pod, and the software has been made to be able to interpret this token and without having to restart. It basically just reads it every time it needs it, and this was the best way that I found to deal with the fact that we can't automatically just refresh the token and keep it alive forever. All right, then we also have the token slinky YAML file, and this is basically a way to create this a token for it, so that it can actually authenticate to the SlurmRest API. All right, so next thing we're going to do then is we're going to let me see here. We're going to, oh, actually, I already deployed it, right? So as part of that command that I ran earlier, I cloned the repo, and then I basically applied the things in this deploy folder. So that's why you basically have the deployment apps Squire created, and the token also was created. It's unchanged because I have already run it before. All right, the next thing we're going to do is the following. I want to change a few parameters here because by default, some of the arguments in Squire, sorry, so some of the defaults expect these defaults here. So these are the thresholds that we use. This is like the grace period, the idle window, zombie after, etc. So we use things like what is the warm-up ceiling, right? So it just gives the jobs a little bit of time to load, so that if they're not using GPUs immediately, it's okay. We give it a 15-minute time period or slots by default before we start considering are they healthy or not. And by default, we also can specify that the job will be flagged as zombie after 2 hours of being idle. But for demo purposes, I do not want to use these defaults. So what instead I'm going to do is I'm going to patch the pod by pushing it a couple of different values. So you'll notice here that we're passing a grace period of 3 minutes, telling Squire to treat the job as zombie after 10 minutes, expecting the idle window to be 5 minutes, and also setting a dollar rate, right? So we don't actually set a dollar rate by default on the Squire container image, but I wanted to set, for my demo, I wanted to set the actual amount of the cost for the GPUs per hour based on what I'm currently paying at AWS for those multi-core, multi-GPU core machines. All right, let's just wait another couple of seconds for this to finish. And what we're going to do next is after we patch the pod, we're going to have a Squire pod running on our Kubernetes cluster, and we can basically interface with it. Okay, so next after this, we're going to basically do a little port forwarding on port 9101. And we're going to then consume the metrics endpoint so that we can see that Squire is up and running as expected. All right, let's just give it another minute here. while this is running, I'll maybe talk about some other items in here. So let's see here. There's a couple of new files. We have a changelog file with all the changes, and the README file has also been kept up to date with all the latest improvements that I've added to it. All right, this is still going, so I might pause the video for a second, not to make the video boring, and I'll resume in just a bit. Thank you. All right, I think I detected the issue. I think I left some stuff running here that I shouldn't. So we're gonna first delete the existing pod, and we're gonna just start over this step here. All right, so you just see my notes here, and here we go. Okay, so just gonna start from scratch here. Okay, so let's clone again. Next, we're going to patch the Squire container. All right. I see that it's running this time. So I just need to give it a second. Before we were having an image pool issue. And here we go. Finally have it. All right. So I apologize for that distraction. Next thing we're going to do is we are going to set that port forwarding that I mentioned earlier. So we're going to port forward port 9101. This is the metrics endpoint and also the web interface for Squire. And what we're going to do next is we're just going to do a little curl request so that we can retrieve that /metrics endpoint and see that we are indeed running version 0.1.0 of Squire. Now, if we basically just query the entire metrics, you'll see that we now have quite a bit of information here. These are all metrics that can be pulled into Prometheus to help it determine and flag utilization and whether things are zombies and things like that. Spoiler alert, there's one right there. All right, next thing we want to do is actually want to show the web interface. So what we're going to do now is we're going to go to localhost port 9101 instead of going to the metrics endpoint. And what we're going to see here is that there's an overall summary and then an allocations finding and configuration finding or findings section. And what you can see here is that that first train 1 GPU job, it's currently being flagged as healthy. And just right-sized, just based on what we're seeing that it's utilizing. It seems that it has the exact resources that it needs. Then there is a zombie. So there's a job here that is requesting 1 GPU. It's that hold 1 GPU, the evil zombie job, but it never actually achieved any GPU utilization. So we now flagged it as a zombie, and it already wasted 35 cents because of that. And then on this next one, we have the train 2 GPU. You'll see that it's asking for 2 GPUs, but it only used about 50% of it because it only uses a GPU, like I said, right? So it's requesting 2, but only using 1. So we're basically flagging it as healthy because it is a GPU job, but it is over provisioned. So we're wasting time and money by basically allocating that, and that's exactly what we see, right? We never needed a card this large for this job. Then if you look at the allocation findings, you'll find an allocation finding for the job 276 and one for the 277. And it's basically saying that the hold one GPU, it's blocking idle allocation. So it has one GPU that has done no work, while there's another job that actually is waiting for a GPU. Then on the 277, the train to GPU, you basically see that there's a block idle allocation and partially used allocation, where one of the two GPUs has done no work, while one job is waiting for one GPU. So we're basically not doing a good allocation of resources, and this is warning the users or admins of that fact. Lastly, for the configuration findings, this is the same type of stuff that you see on squire-lint, but the web interface shows that in a single panel. You can see that 272 currently has no wall time, so because of that, the scheduler cannot backfill around it. So this should be corrected. And the dependency doom1 that can be improved by an admin configuration by basically changing slurm.conf to kill any invalid dependent jobs. Okay. All right, next thing we want to show here is there's actually a few filters, because this is all fine and dandy for my system because it's very small, but if you have a lot of jobs, this could get overwhelming. So there's a couple of rules that you can pass here, like GPU request never touched, and if you pass that parameter there, you're basically asking the server to filter by just the rules that you're interested in finding. If you go to the README of the Git repository, you'll find that there's rules here, and you can find a list. Sorry, let me actually go back to the top here. Rule. Here you go. You can see the list of rules that can be filtered on in here. Next thing I want to show is I want to basically show that we're going to cancel that hold one GPU job. That's basically the zombie, and you're going to see what you would expect, which is Slurm is going to be smart, and it's going to take over the sorry, not this queue. This one here, not just for the pending. You're going to see that when we cancel the hold one GPU job, the zombie, we're basically going to be able to fulfill the wait one GPU job, because there will be enough resources for it. So there it is. We got rid of the hold one GPU, and now the wait one GPU is currently running. Next thing I want to show is the squire-me application. So for squire-me, as you probably remember, a couple of minutes ago, I downloaded the binary, the precompiled binary from the GitHub repository, and deployed it into the login node. So what we're going to do now is we're basically going to log in into the login node, and we're going to point the Squire URL to the REST API, and we're just gonna sorry, not to the REST API. I apologize. We're gonna point the Squire URL to Squire, to the pod that is running Squire, and we're gonna run squire-me. Okay. Now, this is cool because this is something that end users can run. And as long as you have Squire fully up and running, so the difference between squire-lint and squire-me is that squire-lint is standalone, as I said. It can run it on a Slurm cluster with the slurmrestd API service. This one, the squire-me, actually requires Squire. The reason for this is that we actually want to show Squire insights, so we need all the metrics. We need both access to the REST API, the Slurm REST API, and also Prometheus, so we can get the DCGM telemetry. Okay, so the way this works is squire-me is a Go CLI application that will connect to the Squire to a Squire instance, and it will basically ask the service to say to send back all the jobs that the user owns, so that the user can get insights into their own jobs. Now, of course, they could access the web platform, but this allows them to do it directly from the shell. And another really cool feature that I added is the ability to actually output in JSON format. so that this can be accessed programmatically in case the user actually wants to automate canceling zombie jobs and things like that. The user would be able to basically just run squire-me and then interpret the JSON to take action on it from a script. Similarly, notice how you can also pass rules to it, just like on the web. So again, on the web earlier, I showed you that there was rules that you could pass to basically filter the data that comes back. And similarly, on when running squire-me, you can also pass a rule like partially used allocation, and it will filter to just give you the insights for things that obey that rule. All right, next thing we want to do is, just to wrap up, is we're going to cancel the dependency doomed job and the CPU no time, and we're going to submit a new job. And what we're going to see here is that if you look at the SQ, we're going to see that we now have everything up and running. And let me check my notes here. Yeah, and now if we run lint, we're gonna see that the lint will reflect that. Okay, so right now everything's good. So it's just saying I checked 4 of the 7 jobs, 3 have already finished, and I have no findings. Why? Because everything is good. You're not asking for anything weird like a job with no wall time that would basically be impacting the scheduler's ability to backfill, and you're not asking for weird resources like but basically waste resources where you have one job that just requires CPUs running on a machine with GPUs, and basically hogging the GPUs for other jobs that could be used for other jobs to run. All right, and that's pretty much it. Hopefully you guys enjoyed it. Again, to recap, we have Squire v0.1.0, and the menu features are the web interface, but also the squire-lint, which can be run against any Slurm cluster as long as you have access to the slurmrest API, and also the squire-me, which is an end-user tool that allows users to check on what Squire thinks of their jobs. Are they running efficiently, or are they actually wasting time and money and resources? Well, thank you very much.